Hey pals!
As you can probably tell, your skull is made of thick bone. 22 thick bones to be exact.
But your skull wasn't always that strong. Trace your life back to your days in the womb.
You probably can't remember much. That's why we are going to explain what exactly your skull was like when you were in the womb, and when you were merely just an infant.
When you were in the womb, your skull began to ossify. Intramembranous ossification is the gradual transition of a baby's skull bones from a fibrous or cartilage template to hard bone.
Stay tuned for some more facts about intramembranous ossification.
This is an enlarged model of an infant skull. As you can see, the skull is made up of many parts. The green clay represents the bone plates which were formed in the womb, and the brown clay represents the sutures and fontanelles made up of connective tissue, which allow for the passage of the head through the birth canal at childbirth and allow the brain to grow as time goes on. We are now going to take a closer look at how these sutures eventually ossified to become hard bone.
Connective tissue forms in sheets at sites where flat bones, or intramembranous bones, will eventually be. These connective tissue sheets are highly invested with blood vessels. Some of the cells in the connective tissue sheets differentiate into osteoblasts.
Now, we have connective tissue sheets which contain osteoblasts within them. These osteoblasts begin laying down the bone extracellular matrix, forming spongy bone. These osteoblasts get trapped within the hard matrix and are then called osteocytes.
This forms the basis from which the bone will finish developing. At this point, we haven't made any compact bone yet. That is our next task. There are more and more osteoblasts forming from the connective tissue sheets as time goes on, but the newer osteoblasts cannot enter the spongy bone. So instead, they begin to accumulate on the edges of the spongy bone. There, they lay down more hard matrix, but now as compact bone.
We are now going to show you a more detailed version of intramembranous ossification to help you better understand.
Ossification, bone is generated on or within fibrous connective tissue membranes. As the process begins, mesenchymal cells differentiate into osteoblasts in regions called ossification centers. The osteoblasts secrete osteoid or uncalcified bone matrix. Over a few days, osteoblasts become osteocytes, and calcium and other mineral salts are laid down, hardening the matrix. The bone matrix develops thin columns of bone called trabeculae, which fuse to form spongy bone. Blood and lymphatic vessels grow into the surfaces of the newly formed bone and develop red bone marrow. Outside of the bone, a dense layer of connective tissue called the periosteum forms. Most outer layers of spongy bone are eventually replaced by compact bone, but the center remains spongy. Intramembranous ossification also occurs with skull bones in childhood. At birth, skull bones are separated by fontanelles, or soft spots, and sutures, immovable joints made of fibrous tissue. Fontanelles in the fetal skull allow for easier passage through the birth canal and rapid brain development. Up until adolescence, the fontanelles slowly ossify into sutures, providing the brain with greater protection.
What you have just observed does not occur overnight, but rather it is a process that lasts until the baby is about 2 years of age. The skull bones of animals ossify quicker than the skull bones of humans. Therefore, by the time they are born, their brains and skull bones are more developed.
That is why, if you were to observe a baby animal, they are much more independent and less fragile than a human infant.